In this example, we're asked to find the exact value for sine at an angle of A minus B. And we don't know what A and B are, and we really don't need to know because we know the side lengths of at least two of the sides of the reference triangles for each of the angles. The first thing that we're going to want to do is find the missing sides of these triangles using Pythagorean theorem. And so I can see that I have the opposite side is 24, the hypotenuse is 25. Through Pythagorean theorem, you would find that that side length is then 7, this smaller one here. When my other triangle, you can see that this adjacent side is 15, the hypotenuse is 17, and so the opposite side would be 8. Now that we've found all of the side lengths, I need to find the ratio of A minus B. And so we're going to use the formula that I have up here, the sine difference formula. And so to find the sine of A minus B, I know that I need to take the sine of the first angle A times the cosine of the second angle B and subtract cosine of the first angle times sine of the second angle. And so I need to find all of these ratios then to plug in. And so looking at my angle A, the sine's ratio at that location would be opposite over hypotenuse, which is 24 over 25. The cosine at the other triangle is going to, here's triangle with angle B, the adjacent is 15, and the hypotenuse is 17. I'm then going to subtract the cosine of angle A, so going back to this triangle with angle A, and I'm going to have the adjacent side, which is 7, over the hypotenuse, which is 25, and then the last one, going back to the triangle with angle B, the sine is 8 over 17. Now, before you want to just type this into your calculator, keep in mind that we are searching for an exact value, so we want to avoid decimals here. And so we're just going to multiply these fractions. And so if I take 24 times 15, that'll end up giving me 360. 25 times 17 is 425. I'm going to subtract 7 times 8, which is 56. We're going to have the same exact denominator, which makes this very convenient since we're about to subtract the two fractions. We have no work to find a common denominator. 360 minus 56 will give us 304 over 425. It's not a pretty number, but it is our exact ratio for the sine of angle A minus angle B. Now, one way that you could check your answer is we could actually find what these angle measures are by using inverse functions. And so I could go ahead and take tangent inverse of 24 opposite over adjacent, so 24 over 7, and that would give me angle A. Angle B, I could do something very similar, take the tangent inverse of 8 over 15, and then we could find what these angles actually are. So in degree mode, I'm going to take tangent inverse of 24 over 7. We end up getting a 73-degree angle is represented by angle A here. Tangent inverse of 8 over 15 gives us this 28-degree angle here. And so keep in mind I was looking for the sine of the difference between the two. So I'm going to find the sine of the difference between the two angles, and I get an approximate ratio to be 0.715. Well, I can compare that to my exact ratio here, which is 304 divided by 425, which ends up being the exact same ratio. So that's one way that you could verify that, yes, this is correct.